Hello everyone, this is Sedi and welcome to Sedi's Mathverse. For today's video, we will discuss something different. We will discuss one of the topics in high school physics, which is about vectors, specifically component method. It will be my first time discussing a physics topic here in Sedi's Mathverse. So, if you want to suggest something or if I made any mistakes, freely leave a comment below. Without further ado, let's get started. So first, let us give the definition of a vector. Vector is simply a measurement which contains two quantities, the magnitude and direction. Magnitude refers to the numerical part, and direction is direction, the path of the vector, or path taken by the numerical part. A vector is expressed as a letter, for instance, let's say M, then a small arrow. The magnitude of a vector is expressed as the same, only with an absolute value enclosed in it. So this is the vector itself, and this is the magnitude of the vector. To begin with explaining the component method and how it is used, I will give a problem. Two vectors, vector A and vector B, have the following measures. Vector A is 4 meters, whose direction is 60 degrees northeast, and then vector B is 3 meters, heading 45 degrees southwest. What is the measure of the resultant vector formed by vector A plus vector B? A vector can have two or more components depending on the dimensions given. However, since it only involves 4 directions, north, east, west, and south, then the components of the vector is exactly 2. We have the x component and the y component. As we can see, the x component is denoted by the vector letter, let's say M, and then x as a subscript. Then, the y component is the vector letter with y as a subscript. The formula of each component is the magnitude of M multiplied by cosine theta. Theta here is the angle they make with respect to the x-axis, which means that this one, if it is northeast, this one, if it is northwest, this one, if it is southwest, this angle, and lastly, this one, if it is southeast. The given vectors are vector A, which is 4.0 meters, 60 degrees northeast. We will find the two components, the x and the y components of A. Since this is 60 degrees northeast, we can draw it as this one. This is 60 degrees, and the magnitude is 4 meters, 4.0 meters. So we have the x component, 4.0, multiplied by cosine 60. Since it is east, it is going east, it means that this x component must be positive. If it is west, however, it becomes negative. So, 4.0 cosine 60 is equivalent to 2.0 meters. On the other hand, the y component is denoted as 4.0 sine 60 degrees. It is north. Since it goes in the north direction, it means that the y component must be positive. So, 4.0 sine 60 is equal to 3.46 meters. How about component B? Component B is 3.0 meters, 45 degrees southwest. This implies that the x component of vector B is 3.0 cosine 45 degrees south. Since this goes south, we know that the direction is negative, which means that we put a negative sign beside this one. So we have 3.0 cosine 45 is equal to 2.12 meters. Then, the y component, negative 3.0 sine 45, negative 3.0 since it goes south. This is what it looks like. Which means that it is the same, negative 2.12 meters. It is important to know the signs of each component, since this will help in finding the overall direction of the resultant vector. But first, how do we get the resultant vector? In finding the resultant vector, all we have to do is to firstly find the sum of each component. The two resultant components, r sub x and r sub y, are obtained by obtaining the sum of all x components and sum of all y components respectively. Remember from earlier, we got the x components, x equals 2.00 meters and b sub x equals negative 2.12 meters. Adding both of these gives us 2.00 plus negative 2.12 equals negative 0.12 meters. On the other hand, a sub y equals 3.46 meters and b sub y equals negative 2.12 meters as well. Adding these two gives us 3.46 plus negative 2.12 equals 1.34 meters. And now we get the resultant components, x and y. Now that we have obtained the resultant components, r sub x equals negative 0.12 meters and r sub y equals 1.34 meters, we can express the resultant vector in two different forms. The first form being the IJK notation. This is a vector form used for 3 dimensions, but since we will use the x and y dimension, we will use I and j hat only. So, we can express the resultant vector r as the resultant component x I hat plus resultant component y j hat. Given that, we can express the resultant vector of our problem into resultant vector is equal to negative 0.12 I hat plus 1.34 j hat meters. This is one form that we can use. However, if we want to be specific about the distance or the measurement And the direction, we will use the other form, the bearing form. Number 2, bearing form. In getting the other form, first we will find the magnitude of the resultant vector. This is the formula for that. So we have negative 0.12 squared plus 1.34 squared enclosed in square root for the resultant vector. This gives us 1.81. And simplifying it gives us 1.3454 meters. We can round it into 2 decimal places, 1.35 meters, or it depends on the number of decimal places or significant figures you are required to round off. And now that we know the magnitude, let us proceed with the direction. Alright, now we're finished with the magnitude. We know that it is 1.35 meters. Now, we're off to find the direction. So we have theta equals arctangent, the resultant component of y. So we have 1.34, then the resultant component x, negative 0.12. This is arctangent of 11.1667, which is equivalent to, negative 11.1667, which is equal to negative 84.88 degrees. Considering the dimensions earlier, we know that the resultant component x is negative, which means that it is west. Then the resultant component y is 1.34, which is positive, so it goes north. This means that our theta is 84.88 degrees northwest. And this is our direction. Overall, we will express the resultant vector in this form. Vector r, or the resultant vector, equals 1.35 meters, 84.88 degrees northwest. And this is our resultant vector. Here's a bonus problem that you can solve. On a cold, windy night, Harold hunted for animals with his bow to have food for dinner. He spots a wild pig and shoots an arrow with a constant velocity of 80 meters per second, going at the direction 32 degrees northeast. However, the wind, with speed 60 meters per second, is going at a direction 46 degrees northwest, and it changes the direction of the arrow. What is the speed and direction of the arrow? If you want to solve this problem, show your solutions in the comment section below. That is it for today's video, ka-Mathverse. I hope you learned something and enjoyed this video. If you did, subscribe to our official YouTube channel and follow our social media accounts whose links are shown here. That is it, guys. And remember that mathematics is incomplete without you, and chase your greatest moonbeams. Till next time.